Welcome to our Java lecture on fundamentals, part 1. So these are all the points we are going to treat or look at under fundamentals, part 1. Primitive types. These are the most basic data types available within the Java language. We actually have 8 of them: boolean, byte, char, short, int, long, float, and double. So these types serve as a building blocks of data manipulation in Java. And such types also serve only one purpose. They're just containing pure, simple values of a kind. So this is a definition from Wikipedia. So in this diagram, you can see a primitive type, its size, its minimum value, maximum value, and its corresponding Repo type. So reference types. These ones, they refer to an object. They do not hold the value of the object they refer to. They only hold memory address. You can think of them as a road sign. When you say string name equals to hello world, name here is pointing to an object of type string in memory or in the heap. So reference type versus primitive types. Reference types can be assigned to null, which means they do not currently point to any object in the heaps, but primitive types cannot. So if you actually come here and say int x equals to null, this is an error because int is a primitive. But any reference type, string, this will work. Main also, because main is our class name, this will also work. Point 2, reference types can be used to call methods defined in their blueprint when they do not point to null except for static methods. Primitive types do not have any methods associated to them. So what does this point mean? When we say reference types can be used to call methods defined in their blueprint when they do not point to null except for static methods. Let's see what this means. This basically means that if you say main here equals to x, so this method is defined in the blueprint. What is a blueprint? This is a blueprint. A class is a blueprint for creating an object, or you can think of it as a template. So a method defined in the blueprint, if you try to say x.test, this will result in a null pointer exception because this x reference type is pointing to null, and the method you are trying to call is not static. That is what that point means. But if you change this method to static and you run this code, this will work and it won't result in any null point because a static method does not require an object to be realized. That is exactly what this point is actually explaining. Number 3, reference types have definitions which can be viewed like class definition. Primitive types do not. You do not know how a primitive type is defined. In fact, the JVM or the compiler, when it sees a primitive type, it knows what to do. So in terms of what it does, how is it defined, it's outside the scope of this lecture. So all primitive types have lowercase names. So by definition here, we mean a blueprint. For instance, if you want to see how a string is actually defined, you see that public final class string, you can see what it implements, everything else, and how it's defined, all the methods inside the string class. But for a primitive, you can't do that. Default initializations. So Java has a concept of default initialization. Variables get values by default, even without a programmer's explicit initialization. So local variables must be initialized before use. Although they are given garbage data by the compiler will not allow you to read them before explicit initialization. And all non-local variables are set to their respective default values. So let's review this quickly about default initialization. So if you have a variable here, it doesn't matter if it's an instance or static variable. But for now, let's start with a class variable. If you say system.out.printx, or let's just say main. Let's access it statically. You say main.x. If you run this program, although you didn't give x a value, it's already given a default value for an int. As you can see, it's 0. If you remove it, the static keyword, to make it a class variable, obviously you will need to create an object. I'm just going to create an object on the fly and access x. So if we do this, it will give us x as 0 as well. But for local variables, if you say int x, let me just remove this one, and now try to access x here, this will result in an error. You have to initialize it explicitly before you can have access to it. You cannot just access it just like that. So all variables have their corresponding default or the appropriate default values. And a default value for an int is 0, for a byte is 0, for a short is 0, for a long it's 0 also. This L just shows that it's a long. For double it's 0.0. For float it's 0.0. For boolean is false. For character, this is it. For object is null. So if you have string str, I'm just gonna make it static for demonstration. Then say main.str. So since this is not a primitive, if you print, you're going to get null on the console, because all objects are given null by default. Primitive type promotion. This is one of the most, I would say, topics that most people, they don't talk about. So if two variables have two data types that could be different or the same, or let's say they're different, Java will automatically promote the smaller one data type in terms of bytes to a larger one, so that two can perform an arithmetic or a binary operation. What does that mean? If you have this case of int x equals to 1, or let's not just say x, let's say byte x equals to 1, character y equals to 1. If now you want to perform an arithmetic operation on these two, for now let's consider it to be a plus. So if you say x plus y, the resulting type of this arithmetic operation is an int. So now let's just prove that. Let's say byte a equals to x plus y. This is wrong. Why? Because the resulting type here is an int. So this will only work if we put an int or any primitive type that is higher than an int in terms of bytes, or in terms of bits, or floating point types. So if we put an int, this will work because int is 32-bit. If we put long, it will work. Long is 64-bit. If we put a float, this will also work. But now, if we put an int, let's start if we put an int. If we put an int, this works fine. We have this promoted to an int and this promoted to an int. An addition is performed, it results in an int. If we put a long, why does this happen? Or why does this work? It works because although the resulting type is an int, the compiler will continuously perform a promotion to make it a long. If we put a float, the compiler will first make this an int, perform an arithmetic operation. Then we both have int as a resulting type. It checks on the left, what type do we have? It's not an int. It promotes it to a long. It checks, is it a long? No, it's not. It takes it down to become a float. But if you have something like this does not prevent you from for it to work. You will have to do what we call explicit casting. You can actually put a byte here, but obviously you will have to put this in brackets to say you want to convert this result into a byte. But when you do this, you might lose some data. That's why you have to be careful when you do type casting. So we see that if one of the variables is an integral and the other is a floating point, Java will automatically promote the integral to the floating point type. So if this one was a float and we remove this, the only way this will work, if we put an int, this won't work. It will only work if we put a float or if we put a double, because a double is bigger than a float. Why? Because if you put a float, what happens is that x will be promoted to a float, and you have a float and a float to perform an arithmetic operation, you result in a float, and on the left it's a float. But if you put a double, the reason it works is because even though the resulting type is a float, the compiler does further promotion to a double. You see that smaller data types, namely byte, short, and char, are first promoted to an int anytime they are used with Java binary arithmetic operator, even if neither of the operator is an int. So we have already seen that here, if we have char, or let's just say we have a byte. One would think that if you put byte here, this should work because x and y, they are both bytes, so their resulting type should be a byte. But anytime we have an arithmetic operation on those ones, they are first promoted to an int. So the only way this will work is that you have an int here. It doesn't matter, even if here this was a character, operate the same. If you put a character, you will still have the similar issue. If you do this, this won't work. You will have to make it an int, or a long, or a float, or a double. That's about it with type promotion. Variable scope: local, variables, instance, or class variables. These are all the scopes we have. So local variable, any variable declared in a site, a method, conditional statement, or a block is local in that area where it's been declared. So let's see what a local variable can look like. This x is a local variable because it's declared inside a method. You can also have a situation where you have what we call an instance block. So if you have this, you say int h equals to 0. You can also have another instance block and say h, give it another value. So although you have h 2 times, they are in different scopes. That's why the compiler does not complain. Or maybe if you give it inside a static block, it doesn't matter. It still behaves the same way. Or if you put it in an if statement, it becomes local. Int h else int h equals to 0. All these are local variables. Then we have instance variables. These variables belong to an object, meaning they are only realized after a creation of an object. Then we have static or class variable. These variables belong to a class. They are accessed via a class name. No object is required to realize them. So let's see what that means. This essentially means that let me just say create a new class here. We can call it animal. Then private, or not me, let's just make it public for demonstration purposes. Int h public string name. Let's make this one static. So now this class name has two types of variable. The first one is an instance variable. The second one is a static variable or a class variable. So the difference is that for you to have access to h, you must have an object. So in other words, you cannot say a main, okay, let's just say out. You cannot say main dot h. This won't work. You need an object. What you need to do is to say new main dot h. Let's see, new main dot, okay, so animal, I'm sorry, it has to be animal dot h. So if you run this code, because you have so what I have done here is I've created an object on the fly, then I say h. But for the other one, name, I just need to say animal.name. I don't need an object because it's a class variable. So that is the difference. You've already demonstrated that. Then object. So object is a parent of all objects in Java. It's a superclass of all objects in Java, and it has specific methods that are really important for developers to be aware of. The equals method, which is normally overridden to define how objects are deemed to be identical to one another. Then we have a hashCode, which is used mostly with collections to determine the hash value of an object in question. Then we have a toString method used to determine or to give to the string representation of an object. Then we have a finalize method, which was used to perform cleanup before an object is garbage collected. But as of Java 9, that method is deprecated. So let's just see this class before we conclude this lecture. So object O. So this is the class. Even the Java doc mentions that it's the root of the class hierarchy, the superclass of all objects. We are even told that all objects, including arrays, implement the methods of this class. So I would like us to focus on the finalize method. The finalize method, as you can see, it's deprecated since Java 9. That means the upcoming versions of Java, this method will be removed completely. So there are reasons here in the Java doc as to why the method has been removed, but that is outside of the scope of this lecture. Then destroying objects. Unlike other languages where you must manage memory, Java performs memory management for you through a garbage collector. So garbage collection refers to the process of free memory in the heap by deleting objects that are no longer reachable, or objects that are no longer referenced, or objects that have gone out of scope. So all Java objects are stored in the heap, the pool of unused memory allocated to Java objects. So if the application keeps instantiating objects in the heap without freeing that memory, it will soon run out of memory, thereby throwing an out of memory exception. So let's demonstrate what we mean by an object has gone out of scope, or it is no longer referenced. So if we have animal A equals to new animal, and then you do something here, and then at the end you say animal equals to null. You see that this animal that was initially pointing to this object in the heap has been dereferenced to point to null. So now sorry, the question that you will need to ask yourself, what happened to this object? That comes now the issue we say that object is no longer reachable, or it has gone out of scope. The garbage collector now will see that this object is not referenced anywhere in the application. It will then take it out of memory and delete it. There are many scenarios to garbage collection that I may not actually be able to mention as of now, but in the nutshell, that is how garbage collection works.